For number 31, we need to find the inverse function of f. So to simplify the notation, I'm just going to write y equals square root of x to start, and then interchange your x and y value. Okay, and now I need to resolve it for y. So I need to take that statement, I need to square both sides in this case. So I get x squared is equal to, and the square cancels the square rooting, that's why I picked it, to get just y. And I like my y on the left, so y equals x squared. Okay, that's part A. For part B, they want us to graph both of these on the same coordinate axes. Okay, now there's a slight problem. So let's start with the original. The original says y equals square root of x. Let's do a chart on that. Okay, for a square root function, you cannot square root negatives. So if I can only use 0 or positives. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Alright, and I could keep going. And if I plot these, 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 9, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Alright, so the square root of x function is going to look something like that. Okay, now for the one I just made. Okay, now because in solving for y equals x squared, I interchanged the x and y values in order to do that. So I can do that with the chart values as well. Well, 0, 0, okay, that'll be the same. 1, 1 will be the same. But 4, 2 will become 2, 4. And 9, 3 will become 3, 9. And now if I graph these, 0, 0, 1, 1, 2, 4, and 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the inverse function will look something like that. Now, if you were to graph this on the calculator as y1, okay, the calculator would show a graph on this side coming down, as it should on it. Okay, but we can't use that because of the fact from the original function given, the y equals square root of x, you can't square root negatives. Okay, so you'll never get, so when you do interchange the values, you'll never get coordinates that make the other half of the y equals x squared function. Okay, so you don't want these dashed lines over here at all. Okay, you only want the blue that I have solidly graphed. That is your inverse graph. Okay, now part C, describe the relationship between the graphs. Well, the relationship, whenever you do the inverse, they should always reflect over the line y equals x, which I'm doing here in green. Okay, so whatever the original graph is, it should reflect like a mirror across the other side, which it would. Something to note, so if I were to put these dashed lines back in here, well, those wouldn't come from anywhere, from any of the original graph. There's no reflection for that dashed line to be there. So again, that's another way to kind of see that it doesn't belong there. So let me get rid of those dashed lines. Okay, D, state the domains and ranges of f and f inverse. Okay. Well, the domain, let me do the red one first because that was the first one. So y equals x squared. The domain is x greater than or equal to 0, and the range happens to be the same. Okay. Now for the blue graph, y equals x squared. Okay, well again, in solving for the new function, I had to interchange the x and y, so here you can just interchange the x and y for the domain and range. Okay, now the domain is always x and the range is always y. What I mean is, this part will now become x greater than or equal to 0, and this part comes down as the range, but as y greater than or equal to 0. It's kind of misleading for this problem because it's like, well, you didn't really change anything. It turned out the same thing. That's pure coincidence in this case. Okay.